All right, here we are. So let's look at these two triangles up here. Okay? For these two triangles, their measurements are shown. Do they look similar? Yeah, they kind of look similar. Now, for similar figures, the first question of the quiz yesterday said, all the angles need to be congruent. Are all the angles congruent? Well, we only see two of them. We got to figure out the third ones. So, how many degrees are in a triangle? 180. 40 plus 60 is 100. So what's this up here? 40 plus 60 is 100. What's this? Are all the angles congruent? All right. So the angles have to be congruent. For figures to be similar, the sides have to be proportional. Let's figure out if they're proportional or not. We'll start with this one. Boom and boom. 32 over 40. What number goes into both 32 and 40? Bigger than 2. 8. There you go. So that's a 4 to 5 ratio. 36 and 45. What number goes into both 36 and 45? 9. 4 to 5 ratio. 24 to 30. What number goes into both of those? 6. Divide them both by 6. 4 to 5 ratio. Since they're all a 4 to 5 ratio, they are all proportional. So the sides are proportional. The angles are congruent. We have similar figures. Now, wouldn't it be nice if we wouldn't have to look at every single angle and every single side? Yeah. So we're going to get to that. This. Are these two triangles congruent or not congruent? Mr. Bierspot, get out of the congruent. Got to get back to similar. Are these two triangles similar? They kind of look like it. So if we would just turn this, slide this to here, then we could see the angles are congruent and the sides, they're going to be proportional because we got proportions going on, scale factor, all that. So guess what? We'll see in a second. Okay? Now, ABC has a 61 and a 61, and DEF has a 52 and a 61. Are these going to be similar? We got to know right off the bat. What's 61 plus 61? 122. What's 180 minus 122?
48. No, 30. Sorry, that was my bad.
That's all right. At least you're participating. It's 58. Do you see a 58 over here yet? No, but we got to figure out what that is. 52 and 61 is 117. 180 minus 117, 67? 113. I don't know. I had a 7 in the brain because I knew that was going to be a 7 there. Sorry. Yeah, I was cheating. My brain was ahead of my mouth. Okay, so this is 113. 180 minus 113 is 67. How many angles match? Just one. If only one angle matches, the others are going to be different. And what do we say for similar figures? The angles must be congruent. Are all the angles congruent? No. So we have this theorem. This is important. Angle, angle. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar and we don't have to know anything about the sides. Not a thing. Okay, not a thing. Now, the sides will eventually be proportional, but if we know two angles of one triangle are congruent to two angles of another triangle, then the triangles will be similar. Not congruent, similar. Okay. Besides that, we're going to know other stuff too. Let's say we don't know any angles. We don't know any angles. But these two sides are proportional, these two sides are proportional, and these two sides are proportional. If all the sides are proportional, we can turn them, slide them on top of each other, and all of a sudden go, hey, we got some congruent angles going on. we got some similar going on. Okay? So let's see if these look to be similar. A is 3, B is 4, C is 6, about made a 5. D is 9, E is 12, F is 18. Now, what's the ratio from 4 to 12? 1, 2, 3. How about 6 to 18? 1, 2, 3. How about from 3 to 9? It is 1 to 3. What's the scale factor? 1/3, or you multiply everything by 3. Okay? So you're multiplying everything by 3 here. So they're going to be similar because all the sides are going to be proportional. A 1 to 3 ratio. A 1 to 3 ratio, so the scale factor. I would say the scale factor would be 3, though, wouldn't you? Yeah, because you're multiplying by 3. All right. Are these similar? Ooh, some people are saying are a little overconfident. So which side should be matched with what? Should we match the 3 to the 7.5 and the 4 to the 6? The 4 to the 6, but the 3 should go to the 4.5. Go shortest to shortest, 3 to 4.5. Go medium to medium, 4 to 6. And go long to long, 5 to 5.7. All right. Sorry, my dyslexia gets in the way sometimes. All right. 3 to 4.5. Now, working with decimals, that's kind of hard. What if I just go multiplying by 10 and make it 30 to 45? If I'm multiplying each by 10, they're still the same ratio, right? Now, what number goes into both 30 and 45? Bigger than 5? No, not 6. Not 7. 15, thank you. 15 goes into both of these, and it's a 2 to 3 ratio. 4 over 6 is a 2 to 3 ratio. I don't know if this is 2 to 3 ratio. This is the same as 50 over 75, right? So is that a 2 to 3 ratio? If we divide them each by 25 is a 2 to 3 ratio. These are similar. So here we go. What we just used in the last two problems is the side similarity theorem. Does it say all the sides are equal? Are all the sides equal? No, they're proportional. They are the same proportion. They're not equal, they're the same proportion. So if all the sides are proportional, then we're similar. We have a third one that we haven't played with yet, is a side angle side similarity. If the two sides surrounding congruent angles, so if two angles are congruent and the sides that surround those congruent angles are proportional, then we are similar. So this angle is congruent to this angle. Why are these two angles congruent from the first semester? They are what types of angles? Vertical angles. Vertical angles. So this angle is congruent to this angle. Because these two are congruent and these two are congruent, whatever this is, whatever this is, this is. So these sides are basically proportional. So 75, 75, 1, and 1. So this is a 75 to 1 ratio and a 75 to 1 ratio. So these two sides are proportional, these two sides are proportional, and the angle in between is congruent, so we know they are similar. Okay, since they're similar, we need to figure out what MN is. Over here. MN. All right. So how are we going to do that? Well, we just said the sides are proportional. What's our proportion? We just said it was 75 to 1 is our proportion. So that should equal, is it x over 10 or 10 over x? 10 over x. Okay, it's important. If you go in this direction for the first side of the proportion, you have to go in the same direction for the other side of the proportion. All right, how do we solve for proportion? Cross multiply. You could say 75x equals 10 and then divide by 75. 10 over 75 divided both by 5 is 2 over. How about 15? 2 15ths. Okay? Another way you could have done it is take 1 times 10 divided by 75. Same thing. Okay? X equals 2 15ths. All right. This one's a good little problem. Every puts a radio antenna tower in his yard. Ella tells them that their city has a zoning law that says towers can only be 50 feet in height. Avery has to figure out if it's 50 feet in height or not. So on a sunny day, he measures his shadow, and he measures at the very same time the shadow of the tower to see whether his tower is more than 50 feet tall. So the proportion, he knows he's 6 feet tall and his shadow is 5 feet long. So if we go shadow over height, then we'd go shadow over height. What's the shadow of the radio tower? 40. And we want to know the height of the radio tower. That's similar triangles. Okay? And we know they're similar triangles because we know the angle to the sun here and the angle to the sun here is going to be the same. And then if you put the tower up straight and if he's standing straight up, these are 90-degree angles. So by angle, we know the triangles are similar. So if we cross multiply, 5x equals 240. If we divide by 5, we get 48 feet. Is he within the zoning laws? Yes. Yes, he is. So the 3 things we learned today is if we have 2 angles congruent in a pair of triangles, then the triangles are similar. If all the sides of one triangle are proportional to all sides of another triangle, then we have similar triangles. Or if we have 2 angles that are congruent and the sides surrounding that angle, not the opposite side, but the sides surrounding that angle that are proportional, then we have similar triangles. All right. So